So we want to solve the equation cotangent x equal 5 and approximate the solutions which lie on the interval from 0 to 2 pi to 4 decimal places. So I could take the inverse cotangent of both sides, and then I don't have an inverse cotangent button on my calculator. So what I'm going to do instead is I'm going to take the reciprocal equation, so that's going to be tangent x equals, and I'm going to take the reciprocal of that. So now if we took the inverse tangent of both sides, we'd have x equal tan inverse of 1/5, and that is something we can use the calculator. Let's just refresh what's going to happen when we use the calculator. It's going to give us an angle between negative pi halves and pi halves, and of course we're not including the ands, they're undefined values for this. So let's use the calculator. We're in radians. We do inverse tangent of 1 divided by 5, and it looks like that is 0.1974. So our first answer is x equal 0.1974 rounded to 4 decimal places. We knew that that was a value because tangent was positive somewhere in quadrant 1. So where would also have the same sign and this angle for the same tangent value, and that would be down here in quadrant 3 where the tangent is also positive. We found this angle right here, x, and that's the same size as this angle. So we can see to get at the angle we want, I'm going to put it around here in green, to get to that angle, that's going to be pi plus our angle here. So I can get a second solution if I go ahead and take the calculator, and I've already got the angle in there, if I add pi to it. And that's going to be 3.33 and then round to a 9. So 3.339. So here are our two solutions on the interval between 0 and 2 pi that solve the cotangent x equal 5 equation. Now let's go ahead and also look, what if it would have been a negative 5? Well, we would still do the same thing of taking the reciprocals, so we look at tangent x equal negative 1/5, and then we would have the inverse tangent of both sides, and x equal tan inverse of negative 1/5. Well, we know what that's going to be because when we had the positive 1/5 versus the negative 1/5, we're going to get the same kind of answer as we had up here, but with a negative sign on it. But we want to have some accuracy, so we're going to go ahead and not use the rounded version, but I'm going to get the same answer with the negative sign because it's going to give me something in quadrant 4. Now the problem with that is it's not between 0 and 2 pi, so what I need to do is get a coterminal angle, and so I'm going to add 2 pi to what the calculator gives me so that I get an angle that is coterminal to the one the calculator gives me, but it's between 0 and 2 pi. So let's go ahead and do that. So I'm going to do inverse tangent of negative 1/5. And as expected, there's the negative of the same kind of thing we got when we did the positive one. Now we're going to add 2 pi to that so that we get a coterminal angle in quadrant 4 that's between 0 and 2 pi. And it looks like it's 6.0858. So one of our solutions is x equals 6.0858. Now we want to ask ourselves, where is there an angle that would have the same tangent value of this, and that would be in quadrant 2 where tangent values are negative. And so thinking about when we had this first angle here, if I took pi and I subtracted that angle, that would give me the one that I need there in quadrant 2. So let's go ahead and do that. What I'm going to do is have that first angle, which was from inverse tangent of negative 1 divided by 5, and that gave me that negative angle right here. So if I add pi to that, you can see from our picture that I would have an angle here in quadrant 2 that has that tangent value of negative 1/5. So that's going to be 2.9442. So our second solution, x equal 2.9442. Now remember, when you answer these, typically the first answer box wants the smaller angle and then the second answer box the larger angle.